We are going to evaluate these four logs without a calculator. So we're just going to, the strategy here is to change them to exponents and use what we know about rules of exponents to do this. So the first one, log base 8 of 64. First thing I'm going to do is set that equal to x. So if I can solve for x, that's the answer. So I'm going to change the log to an exponent. That would be 8 to the x equals 64. Now I have to solve for x. Now, normally you would try to get the same base here, but I think this is obvious that 8 squared is 64, so x equals 2. And we're done. So the log base 8 of 64 does equal 2. So number 2, we're going to do the same thing. Set this equal to x. Change it to an exponent. 3 to the x equals 1 over 81. Now, unlike the last one, it's not as easy to do this just by knowing it. So we're going to try to get the same base. You could think about this and get the answer without getting the same base, but I'm not going to. I realize they both have a common base of 3. So 81 is 3 times 3 times 3 times 3, or 3 to the 4th. So now I'm going to use properties of exponents, and 1 over 3 to the 4th is 3 to the negative 4th. So now that I have the same base, both 3, I can set the exponents equal to each other. So x equals negative 4, and then I'm done. So the log base 3 of 1 over 81 does equal negative 4. Next one, log base 4 of 1/2. Same thing. Let's set it equal to x. Change it to an exponent. 4 to the x equals 1/2. Figure out what the common base is. In this case, it's 2. So 4 is 2 to the second. That's all to the x. So when you raise that exponent to a power, you multiply exponents. So it's 2 to the 2x. 1 over 2. It's 2 to the first down there, so you bring it up to make it 2 to the negative first, and then set the exponents equal to each other. And so this gets pretty simple, I hope. So x is negative 1/2. Therefore, the log base 4 of 1/2 is equal to a negative 1/2. And then one more. We have the log base 27 of 1 over the 5th root of 9. So change it to an exponential equation. 27 to the x equals 1 over the 5th root of 9. So their common base would be a 3. So 27 we know is 3 cubed. So it's 3 to the 3rd to the x. So 3 to the 3x. 9 is 3 squared. So it's 5th root of 3 squared. So the 5th root is a fractional exponent. That would turn out to be 3 squared to the 1/5, or just 1 over 3 to the 2/5. And now we're going to, now we're going to use properties of exponents, bring that 3 to the 2/5 up, and make it 3 to the negative 2/5. And now that we have the same base, we're going to set the exponents equal to each other. I'm going to multiply both sides by 1/3 to get rid of that 3. So we have negative 2 over 15. So it means the log base 27 of the 5th root of 9, the 5th root of 9 does equal negative 2 over 15. So that's how you evaluate logs without a calculator. And you can only do that if it's possible to get the same base, which it was on all four of these.